So this is the 35th video on rigid body kinematics. This is in continuation of the 34th video. In this video also I'll take up some more discussion of instantaneous center of rotation. Okay. So again, before going ahead, I would like to say that if you go through all these videos, you have complete information is there. You don't have to go anywhere else. And if you go through this and solve the problems for any of the source, I'm sure you will be able to solve most of them. In case you have some doubt, put it in the comment box. I'll see and clarify it. Okay. And all the videos on these have been put in their respective playlists. So you can go to a playlist and see them. Okay. So first, now what I'll do, we'll continue the theory on instantaneous center of rotation. Okay. The theory in instantaneous center of rotation will be continued here. Alright. So now, before going ahead, one thing I would like to say. What is the significance of IC of M with respect to F? Suppose M undergoes plane motion with respect to F. Okay. Suppose at some instant t, P is the IC of M with respect to F. Then what is the significance of IC? That is the question. Okay. So significance of IC is that body instantaneously turns about its IC. That is the significance of IC. Significance of IC is that IC meaning instantaneous center of rotation, meaning the rotating body instantaneously turns about its IC. The rotating body M instantaneously turns about its IC. This is the significance of IC. The body instantaneously turns about its IC. See, the point is that body will turn through that point which is at rest with respect to some frame F. That is the point about which the body turns. Okay, when we say that body turns about its IC, meaning that location of the body is fixed, about which the body is turning. Okay, so that is why we say body turns about its IC. Fine. So that is the significance of IC. Now one thing, we should distinguish two concepts, IC and PC. IC meaning instantaneous center of rotation and PC meaning permanent center of rotation. So what is the difference between these two? Permanent center of what? Rotation. And IC meaning instantaneous center of rotation. See, there is a difference between these two concepts. First, let us take the concept of PC, permanent center of rotation. Permanent center of rotation meaning one location of M is always at rest with respect to F. Same location. Same location of M is at rest with respect to F at all instants. That is called the permanent center of rotation. For example, see, if this is the fixed ceiling, this is a rod which is hinged here. The rod is swinging like this. The rod is swinging. This is a case of permanent center. This rod is turning about its hinge point. That is the permanent center of rotation. Alright. So permanent center of rotation meaning this location of rod is always at rest with respect to ground. So this hinge point of the rod, where the rod is hinged to the ceiling, that is the permanent center of rotation of rod with respect to ground. Okay. So that is the permanent center of rotation of rod with respect to ground. That is the permanent center. So same location of M is always at rest with respect to ground at all instants of time. So that location will be called the permanent center of rotation. And what does instantaneous center of rotation mean? Instantaneous center of rotation means that if certain instant t1, location p1 of M is at rest with respect to F, then dt seconds later, some other location p2 of M becomes rest with respect to F. That is a different instance of time, different locations of M become its IC with respect to F. So the identity of the IC keeps on changing with time. Okay. So at different instance of time, different locations of M are the IC of M with respect to F. So at different instance of time, body turns about its different ICs. I hope is it clear. Okay. So this is the significance of the IC concept. The body instantaneously turns about its IC. And you must distinguish between IC and PC. PC meaning permanent center of rotation. One particular location of M is always at rest with respect to F. And that location of M is called the permanent center of rotation of M with respect to F. As I took the example of this pendulum, swinging pendulum. This point is the permanent center of rotation of this pendulum with respect to ground. Okay, and I'll take up some example of IC. For example, suppose we have a drum. This is a circular drum. The center C, radius R. Center moves ahead. This rotates clockwise, and here the rod undergoes pure rotation. Pure rolling. The drum undergoes pure rolling with respect to ground. Okay. So at some instant, material point D1 of drum is in contact with ground. A drum is undergoing pure rolling on ground. Velocity of location of ground with respect to ground is 0. So from pure rolling criteria, velocity of D1 with respect to ground is also 0. So at certain instant of time, location D1 of drum is the IC of drum with respect to ground. Now what happens? Let us take some other point D2. Now what happens? Sometime later what happens? Center moves still ahead. D1 comes here and point D2 of the drum comes in contact with the surface. So now D2 is at rest with respect to ground. So D2 becomes the IC of drum with respect to ground. So at different instants of time, different material points of drum become its IC with respect to ground. So this is the significance of IC. And this is the significance of PC. Okay. So I have explained fully what is the significance of IC and what is the significance of PC. Alright, fine. Now, one more thing I would like to say. That in general, suppose M is undergoing plane motion with respect to F, then you know that at every instant M possesses an IC with respect to F. Now IC of M with respect to F need not be its material point, it can be its extension point also. That is, IC need not be a material point of the body, it may be its extension point, that is imaginary location also. If you have any doubt regarding real and imaginary location, go to the 7th or 6th video on rigid body on relative velocity, whose playlist has also been put in the playlist has been specified. Okay, so there you will get all the details of real and imaginary location of frame. Alright, so in general, if M possesses an IC, it is not necessary that IC should be a real material point of M. It can be its imaginary location also. So IC of M with respect to F need not be its material point. Need not be its material point. Need not be its what? Material point. It can be its imaginary location also. We can say the same thing other way. IC may be a material point of the body or it may be its imaginary location. Okay. So I'll demonstrate this concept by one example. Okay. This I'll rub it. Okay. So I will demonstrate it by example. Okay. So see, this is the top view of the situation. Here we have a horizontal table, fixed horizontal table. Suppose it is a smooth surface. Here a rigid rod is placed here. Suppose length of the rigid rod is L. This rod is initially static on this table, but is otherwise free to move on this table in any other way. Okay, this rod is static on the table, but is anyway free to move anywhere in any way on the surface of this smooth table. Now initially the rod is at rest. Okay, now what I do, I hit this left end of rod by some other rod perpendicularly. Okay, fine. So let this point be P0. So just after I hit this rod perpendicularly at this end P0, this point P0 begins to move with some speed V0 with respect to ground. And when I just hit the rod also begins to rotate at some angular speed omega with respect to ground. Rod begins to rotate at some angular speed omega with respect to ground. Alright. Now just after the hitting this rod at end P0 by another rod, this left end of rod begins to move V0 at a speed V0 on the table surface, and it begins to rotate clockwise at some angular speed omega. Now let us take a material point, let us take a location P on the rod whose distance from P0 is say x. Now what we do, we apply SRC procedure for velocity between the points P0 and P. So SP arrow P0 and OP arrow P. Okay. Now I give the velocity of selected point P0 to other point P. So I give V0. Now I say the sentence, P moves in a clockwise, since omega is clockwise, P moves in a clockwise circle with center at P0 and radius x. So I give a velocity of omega x to P0, to P. Now net velocity of P is the vectors of these two. So velocity of P will be written as mod of V0 minus omega x. See, I put the modulus because we don't know which is more. This is more, this is more, we don't know. Okay, fine. Now see, one thing I would like to say. So this V0 is a positive quantity. Omega x is also a positive quantity. So, and this here a minus sign is coming. So this means there exists a value of x, say x0, such that V0 minus omega x0 is 0. So solve it. What do you get? V0 x0, V0 by omega. Now see, a location whose distance from P0 is x0, for such a location this minus this is 0. So this means that there is a point on the rod whose velocity just after hitting becomes 0. So by definition that is the IC of rod with respect to ground just after the hitting process. Is it alright? Fine. This 0 becomes 0, meaning there exists a location on the rod whose velocity with respect to ground just after hitting is what? 0. So by definition, that location is the IC of rod with respect to ground just after the hitting process. So this point corresponding, this point at a distance x0 from P0, that's the IC of rod with respect to ground at just after the hitting process. So let this point be, this point at a distance x0 from P0 be, let this point at a distance x0 from P0 be, let this point be say P dash. So that means Vp dash G is 0 just after the hitting process. This means P dash is the IC of rod with respect to ground. P dash is the IC of rod with respect to ground just after the hitting process. Okay. And distance of P dash from P0 is what? x0, V0 by omega. P dash P0, distance of P dash from P0, that is just equal to what? x0, that is V0 by omega. Now two possible cases arise. One case is what? Case 1. Case 1 is that x0 is less than L, more than 0. What does this mean? This point P dash lies on the real location of rod. It's the material point of rod. So in this case, P dash is the material point of the rod, which is the IC of rod with respect to ground. So P dash is the material point of rod. Material point of rod. Material point of rod. P dash is the material point of rod, which is IC with respect to G. G meaning ground frame. So P dash is the material point of rod, which is the IC of rod with respect to ground at the given instant. So in this case, IC coincides with the real location of the rod, imaginary real location, material point of the rod. And second, case 2. Case 2 is this. x0 is more than L. In this case, the point P dash is outside the rod. It is not a real location. It is its imaginary location. So in this case, IC P dash, which is the IC of rod, is not on its material point, but is outside the rod. IC P dash of rod with respect to ground. IC P dash of rod with respect to ground. IC P dash of rod with respect to ground is an extension point. Is an extension point of the rod. So in this case, IC is not the real material point of the rod, but is at its extension point. It is on the extension point of the rod. Fine. IC in this case is an extension point of the rod. Alright, fine. So in both the cases, I draw the diagram. See, in case 1, the diagram just after hitting will be something like this. This is P naught. This P dash is the IC. This distance is x naught less than L. So body is turning about this IC. This is IC in case 1. And in case 2, the diagram is something like this. This is the rod. This is the P naught. And P dash is somewhere here. Distance P naught, P dash is more than L. This is L. And P dash P naught is x naught. X naught is more than L. In this case, IC lies outside the rod. In this case, IC lies on the rod. Alright. In this case, we see that IC of the rod lies on the material point of the rod. In this case, we see IC lies outside the rod. That is, it's an imaginary location of the rod. Okay. And one more thing, just after hitting, the rod is turning about this point P dash IC. As I told just now, the rod begins to move about its IC. The body rotates about its IC. A short time later, what happens? The rod becomes something like this. See, the rod is turning about P dash. In this case, what will happen? It is just after hitting. When in very short time later, rod will become something like this. If you don't extend it here, it cuts P dash here. So in the first case, IC of rod is a material point P dash of the rod, and rod turns about its IC. Rod is turning about IC P dash. In this case, IC P dash of rod lies outside the rod. That is, it is on its imaginary location. In this case also, rod is turning about P dash. Just after hitting, P naught is moving like this. This also is moving something like this. So after a short time, the rod is initially here. Just after hitting, rod becomes something like this. It is turning about P dash. So I hope it is clear. So this proves that two things. First of all, the body turns about its instantaneous center. What is permanent center, what is instantaneous center, I have fully explained. And one more thing, the IC of body need not lie on that body. It can be on its imaginary location, or it may be a material point of the rod. That is real location. Alright, fine. Alright. Now I rub this one. Okay, fine. Now, before going ahead, one thing I would like to emphasize. See the 34th video on rigid body kinematics. That is in the first video on IC. I wrote down the position vector of IC. R is equal to R P naught plus omega cross V P naught F by omega square. This formula I wrote down. This is the PV of IC, position vector of IC of M with respect to F. And P naught is the R P naught is the position vector of some other location P naught of the body M in the same base plane as IC. So this I'll draw the diagram here. See, this is the frame F, alright. This is the body M, which is undergoing plane motion with respect to F. So IC possesses the IC with respect to F. See, this is the base location of F, frame F. This is the location P naught, and this is the P. This is IC. IC of M with respect to F at time t. So this vector is R P naught. This vector is R from O to IC, and this vector is rho. From this the equation we see that this plus this equal to this from triangle of vector addition. R P naught plus rho is equal to R. Alright. So this means that R minus R P naught is what? Vector rho. Alright. And from this equation, R minus R naught is what? R minus R P naught is what? From this equation, R minus R P naught is nothing but omega cross V P naught F by omega square. Alright. So these two equations imply what? that vector rho is equal to omega cross v p naught f by omega square. This vector rho. Vector rho becomes how much? Omega cross v p naught f by omega square. This is the vector rho. Alright. So what does this mean? See, if we evaluate the magnitude of this relation, both sides, rho is the magnitude of vector rho. Rho is the distance between ICP and point P naught. That is same as mod of omega cross v p naught f by omega square modulus. So this becomes, down it becomes omega square, and here it becomes omega cross v p naught f, like this. Now this becomes, if we evaluate this cross product, it becomes what? Omega into v p naught f sine 90 degree by omega square. So this becomes, actually why 90 degree here? Because in plane motion, omega is normal to the velocity of all the locations of m with respect to f. So omega and v p naught f are mutually perpendicular. So from property of cross product of two vectors, this becomes omega v p naught f sine 90 degree by omega square. Sine 90 degree becomes 1. So this becomes v p naught f by omega. So this means what? If p naught is some location of m, then IC of m with respect to f is at a distance of v p naught f by omega from point p naught. This point, is it clear? IC of m with respect to f at time t is at a distance of rho, that is v p naught f by omega distance from point, some other point p naught of m. Now one thing I would like to say, there are many points of m which are at a distance of v p naught f by omega from p naught. So which one? Is it clear what I am saying? What I am saying is this. There are many points of m which are at a distance of v p naught f by omega from point p naught. For example, if you take this p naught as center and we draw a circle of radius rho, so all points on this circle are at a distance of rho from p naught. Now, among all these points, which point of the body m is the IC? So that point which is along the direction of which vector? Vector rho, that is along omega cross v p naught f. That is the direction. Look, is it clear what I am saying? I have said that, first of all I have said that all the locations of m which lie on a circle with center at p naught and radius rho, all such locations are at distance rho from the point p naught. Now among these many points, which point of m is the IC of m with respect to f? That point of m is IC such that we move from p naught in which direction? Along the direction omega cross v p naught f. So if we move from point p naught along direction of omega cross v p naught f, a distance rho, then we reach the IC of the m with respect to f. Alright. Is it alright what I am saying? What I am saying is this. I just re-explain it. This is the frame f. This is the frame m. P naught is the some location of m. P is the IC of m with respect to f, and IC and P naught are in same base plane. This is the distance rho, where rho is equal to this distance v p naught f by omega, and vector rho is along which vector? It is along omega cross v p naught f by omega square. The v p naught f is what? Velocity of p naught with respect to frame f. So this means p naught is some given point of m. From this point p naught, we move a distance rho in the base plane along direction of the vector omega cross v p naught f, then we reach the IC of m with respect to f. Alright, fine. Is it clear? So we start from p naught. We move from p naught a distance rho in the direction of the vector omega cross v p naught f, then we reach the IC of m with respect to f at time t. Is it alright? This is called the IC concept. This is called the concept of instantaneous center of rotation. Is it alright? So m undergoes plane motion with respect to f. P naught is a point of m in some base plane. P is the IC of m with respect to f in the same base plane. Distance between P naught and P is rho, and vector rho is equal to omega cross v p naught f by rho omega square, vector rho. So this means starting from point P naught, we move a distance rho in the direction of the vector omega cross v p naught f, then we reach the ICP of m with respect to f at time t. So that is the IC of m with respect to f at time t. Okay, fine. So this is called the IC concept. So from point P naught, we move distance rho, where rho is equal to this much, along direction of the vector omega cross v p naught f, then we reach the IC of m with respect to f at time t. Then we reach the IC of m with respect to f at time what? T. Fine, alright. So from this equation we see this is just rho. So v p naught f is equal to omega rho. What does this mean? Another thing. A point p naught which is at a distance rho from ICP, speed of that point p naught will be omega rho. Is it alright? Fine. A point p naught which is at a distance rho from ICP of m with respect to f, then speed of p naught will be omega rho. Where omega is the angular speed of m with respect to f and rho is the distance between p naught and p. This also is IC concept. Alright. This also is called the IC concept. Fine. Alright. So, two things I have stated here. How to locate the IC? Given some location p naught of m, from point p naught, we move in the direction of this vector, omega cross v p naught f. And by what distance? A distance rho equal to v p naught f by omega. We reach the IC of m with respect to f at time t. And this implies that if p naught is at a distance rho from ICP, then velocity of p naught, speed of p naught with respect to f is equal to omega rho. Okay. Velocity of p naught with respect to f is omega rho. Alright. Now velocity of p naught at a distance rho from IC is Vp naught f omega rho. Now which direction? Normal to the direction omega cross Vp naught f. It is normal to this direction. Okay. So that will explain just now. So if we write the vector equation from these two, then Vp naught f will be Vpf omega cross rho. This is 0 because I see omega cross rho is Vp naught f. Okay. So velocity speed of p naught with respect to f is omega rho and its direction is along omega cross rho. That is at right angles to vector rho, corresponding to sense of omega. Alright. I love this one. Fine. So this thing I repeat here. So from this equation what do we see? Vp naught f is equal to omega cross rho. So this means if you take the magnitude on both sides, then Vp naught f becomes omega rho sine of 90 degree. Sine 90 degree becomes 1, so omega rho. So a point p naught which is at a distance rho from ICP, the speed of p naught will be omega rho. And direction of Vp naught f will be normal to vector rho because omega cross rho. Omega cross rho is perpendicular to rho, corresponding to sense of omega. So Vp naught f is perpendicular to vector rho, corresponding to sense of omega. What does this mean? Vp naught f is perpendicular to rho, corresponding to sense of omega of m with respect to f. So what does this mean? This means this frame f, okay? This is a rotating rigid body m, okay, in plane motion with respect to f. This is the IC, P is the IC, and P naught is this point, okay? Omega is this clockwise. Sense of omega of m with respect to f is clockwise. This distance is rho. So in this case, P naught, speed of P naught will be how much? Omega rho. And it is normal to vector rho, corresponding to sense of omega, so in this direction. This is Vp naught f in this case. Now in this I assume that omega was clockwise. Now I suppose I take the case that m is anti-clockwise, like this. This is the IC, P is the IC of m with respect to f at time t. P naught is a point in the same base plane as IC at a distance rho from P. In this case, velocity speed of P naught will be how much? Omega rho. And it will be normal to vector rho in this vector, corresponding to sense of omega, so it will be this direction. Vp naught will be omega rho, normal to vector rho, corresponding to sense of omega, so in this direction. Okay, so this is called the IC concept. So IC concept has two aspects. Velocity of P naught at a distance rho from IC has a magnitude of omega rho and normal to vector rho, corresponding to sense of omega. So in those two cases accordingly we'll show this. Okay. And then one more thing I had said, that if from point P naught we move a distance rho in the direction of the vector omega cross V P naught F, then we reach the IC of M with respect to F at time t. Alright. Then we reach the IC of M with respect to F at time t. We reach the IC. Alright. Fine. So this was the 35th video on rigid body kinematics. So in this also I have first, what did I do? I just summarize it. Okay. First I said that in case of I told you what is the difference between IC and PC. Then I said that what significance of IC is that body turns about its IC. Body turns about that point which is at rest, and that is IC. So body turns about IC. Then I said what is meant by PC, permanent center of rotation. I took an example, pendulum case, to demonstrate the concept of PC. Okay. Then what did I do next? Then I said that I took an example to demonstrate the concept that IC need not lie on the material point of the body, it will be outside the body also. I took the case of that rod. Then I took the IC concept, which before IC concept I said that if P naught is some point of M, and the distance of IC from P naught is Vp naught F by rho along direction of the vector omega cross Vp naught F. Then we reach the IC of M with respect to F. Alright. And then I said that IC concept I said a point P naught which is a distance rho from ICP, the velocity of P naught is omega cross Vp naught F. So magnitude of velocity of P naught is omega rho. Direction perpendicular to vector rho corresponding to sense of omega. Two cases I took here, this and this, clockwise omega, anti-clockwise omega. I show the velocity of Vp naught with respect to F in two different cases I have shown. Okay. And lastly I talked of this fully explained. Alright. So I hope what I have said is fully clear, no doubt. Alright. So this was the 35th session on rigid body kinematics. Okay. On 36th session on rigid body kinematics, what I do, I will first of all discuss various methods of locating the IC. Okay. And so this is a result of great significance. See, if you understand this concept, it is very helpful concept sometimes. In many problems, location of IC is known by observation. Then you fully use the advantage of this concept. It greatly simplifies the calculation procedure. Okay. So this will be discussed in the coming videos. So this I close it here. Fine.